Today's problem, the Knights Tour problem. Let's see. Difficulty is medium. Submissions, 14,000. It's not very many for a problem like this. I don't know. It's this is like a classic problem that you probably did in your first programming class, Knights Tour. Now, when you do it in a beginning programming class, they're going to go over the whole algorithm with you, maybe some sample code and so on. So it becomes, an easier problem. Maybe it's an illustration of recursion or something. But in here, it's just like, okay, Knights Tour, go. So you are given an integer, n, and an n by n chessboard with a knight starting at the top left corner. Your task is to determine a valid knight's tour where the knight visits every square exactly once, following the standard moves of a chess knight. 2 steps in one direction, 1 step perpendicular. I see. Okay. For example, if a knight is placed at cell 2, 2, it can move, well, okay, you probably know how a knight can move in chess. It's an L shape. So for any square, the knight has 8 possible moves. I mean, there's no guarantee that all of those moves will actually end up on the board, so you have to check that. You have to return the order in which each cell is visited. If a solution exists, return where is it here? Oh, I see. You have to return the order in which each cell is visited. If a solution exists, return the sequence of numbers starting from 0 representing the order of visited squares. If no solution is possible, return an empty list. Any valid ordering is fine. Okay. I give an example here. You have to kind of take their word for this. Well, I mean, you could you could trace through it if you want to. Wait, what is this? Whoa. Oh, I see. Oh, okay. Well, I'm just wondering about the output here. Output, true. Okay, that means you found the Knights Tour on a 5x5 board. Now, true here means there is no solution for a 4x4 board, but you correctly returned an empty list. So that's also true. N is going to be between 1 and 6. Expected complexities, 8 to the power of n squared. That's not very good. I mean, exponential algorithms are not good, but since n can only go up to 6, we're okay here. And the reason it's 8 to the power of n by n is there are n by n squares, and at each square, you've got to examine 8 possibilities for knight moves. All right, auxiliary space, O of n squared. That's for your board. Topic tags, recursion, backtracking, puzzles. All right, yeah, it's a recursive solution. So you make a move and then you call the recursive method again from the new position. Now, if you get stuck, the algorithm is going to go back and try another move from wherever you failed. Anything else to say about this? All right, let's take a look. I'm going to scoot this over a little. Okay. So the input to this is n. You have an n by n chessboard. We're going to create a class variable called n. We're going to create a class variable called board. These could be, defined in the main method here and then just passed every time into this solve tour method. I don't really like that as much. we have a class variable called found. Now that is going to it's going to be initialized by default in Java to false. All right, for board, we're going to fill it up with -1s. We're required to start in the top left corner, so that is move 0. So after filling the board with -1s, we're going to put a 0 in the board at 0, 0, top left corner. And then we're going to call solve tour. 0, 0, that's the starting point. We'll go over this found here. This is just to, because the requirement is that for some reason, you've got to return this as a list of lists, not a 2D integer matrix. So that this is just to convert from a matrix to a list of lists. Okay, solve tour. If this gets called and ij is, well, the cell at ij, the input cell, is equal to n times n minus 1. That's the maximum number that we can have in a board of size n. That means we've found a solution. Okay, we actually set the value of the next cell here. So by the time the method is called with ij, the cell at ij has already been set. And we're just going to proceed from there. Now these pairs here represent all the possible moves, the 8 possible moves that you can make from a cell. So we're going to loop from 0 to 8, and we're going to examine all of the possible night moves. All right, here's what we got to do. We got to see, is this a valid move? So to be a valid move, the I has to be, well, whoa, hold on. Oh no, that's right. Okay. Next I and next j both have to be greater than or equal to 0. They also both have to be less than n. And the cell at next I, next j has to equal -1, meaning it hasn't already been visited. And if all those are true, then we'll go ahead, add 1 to the current cell and set board at next I, next j to the next integer. And do a recursive call to solve tour from the next cell. All right. Now, eventually that is going to return. It may make additional recursive calls, but eventually it's going to return. And it will either have found a solution or it'll get stuck and have to backtrack. All right. And we'll know which of those is the case by this variable. Found. All right. So if it comes back and a tour is found, return. We're done. If it comes back and it's not found, then what we're going to do is we are going to unset the cell at next I, next j. We're going to set it back to -1. So now it looks like it's unvisited. That is, we set it here and we proceeded to try to solve the tour using that move. If we couldn't solve it, we have to backtrack, undo that move, and go back up here and try the next move. Okay. So let's see. Here's the initial call. Now eventually, after a lot of recursion, that is going to return. And either a solution will have been found or a solution will have not been found. Now, if the solution is not found, that's pretty easy. We're asked to return an empty list. If it is found, then we'll create this list. We're going to go through the board, iterating over the rows and columns. For each row, we'll create a new list called row. We will add the contents of the board for that row into the list, and then we'll put the list, which we've called row, into solution. So it just converts a 2D integer matrix into a list of lists. All right, let's try running it. You know what? Let me do a quick compile check. Okay, that's fine. And let's do it. 6 test cases. All right. That's it. Knight's Tour. You know, you probably seen it before. It's just a classic recursion and backtracking problem. It's similar. I mean, it's similar to other problems that we solved. I remember we had a problem like rat in a maze. Same thing. You know, the rat's in a maze. You can go up, left, down, right. But yeah. So I hope that you will like the video, subscribe to the channels, subscribe to the notifications, and we'll see you next time.